Hello, hi. I'm Newman from Stretch Devices in Philadelphia, a company that developed the Newman roller frames and this Newman Roller Master. These are 10-second snap-in Newman roller mesh panels that are fabric is already perfectly aligned, and all the corners are 100% softened, so we can go right on to the Roller Master. And as you can see, all the different mesh counts are color coded, and about 8 different mesh counts. I'm going to stretch a 205 for you. And these special meshes all have thinner threads, but the meshes are typically between 30 and 60% stronger than all the other meshes that are on the market. So I'm going to show you how to use the snap-in mesh panel and the Roller Master. So there's a thin lip, and that lip goes underneath the lip here. And by the way, we're here in Honduras at the Haynes operation, where we have 19 new Challenger 3s and 3 new Alpha 8s, 22 machines, and about 4,000 Newman roller frames. Now that's all it took was about 8 to 10 seconds to drop the panel in, and you look at that again, goes under, snap, that's it. That's that fast, and you can't put it in incorrectly. It only goes in one way, and it doesn't take any skill to put it in. Now I put the wrenches on from the Roller Master, and these are constant force wrenches. And constant force wrenches mean, because of how they're engineered, which was a separate patent from the Roller Master, no matter what position they're rotated in, the forces from the opposite these two rollers are fed from the same air supply, and they're getting exactly the same force no matter what position. This one's rotated more inward. No matter what position they're in, you get exactly the same force in each direction. You put the wire on the back, so the wrench comes up, and the cable goes right into the slot, and that's it. Now that the mesh is in place, the 4 frames are in place, then we're going to switch this on, put the tension meter in the middle, and both switches go on, and simultaneously all 4 rollers are rotating. And as you can see here, I've got 44 newtons, and as you can see here, I have 42 newtons. And if we look at the uniformity of so we're done, that's it. We just stretched it. So if you just watch it again, all we did was, now we're off, and now we're on, and we're back to the same exact position. That's 43 newtons, and that's approximately 2.2 seconds for the mesh to be stretched. And the mesh wants to be stretched fast and shocked. A very strong polymer, polyester, will stress harden, and the faster you stretch it 4 ways simultaneously, the quicker it will work hard. So you can see that It didn't take any skill, and the time to stretch a frame was the actual time of doing it totally in production would be approximately 40 seconds. And we look at the uniformity of the screen in the print area, and you can see that this is plus or minus a Newton. And we look at on this side, and we're plus or minus a Newton in this direction. So it's perfectly aligned. The corners are perfectly softened so that we can go again from 0 to 43, 44 Newtons in approximately 2.2 seconds.
Do it one more time.
Do it one more time so you can see clearly. Off, on, and we're exactly back in the same place. If we were stretching 100 frames or 1,000 frames at 40 seconds a screen, and they're all going to come out the same because the Roller Master is pre-calibrated and the PSI is at 45 Newtons in this direction, in the X direction, 45 PSI in the X direction, and this is at 38 PSI in the Y direction. That's the calibration that will always bring you to exactly that tension no matter what the mesh count, as long as you have the same frame size. Now I would push down on the two control panel knobs. That locks the air regulators in the same place. Now you never touch them again. So when you're in production, you're just turning the switches on and off, and when you go to retension a screen after reclaiming, you put it on, put the 4 wrenches on, and in 2.2 seconds it's retensioned. Now if you notice, interestingly, the tension is perfectly uniform. The tension meter tells you if the tension is perfectly correct. And you can see how perfectly uniform the screen is. The tension meter is what determines its perfect uniformity. This roller is rotated this far, how many degrees from vertical. This roller over here is rotated, I'd say, approximately about 30 degrees more than that roller, but these two rollers are parallel. They're controlled from the same exact force from these two wrenches, but yet this roller rotated more, which is correct. There's internal stresses that are in all mesh because of the heat, the way weaving is done and heat setting is done, and the machine automatically determines how far the rollers need to rotate for stretching and retentioning. You don't have to know how far they need to go. This roller is rotated this far. This roller is rotated, I would say, 15 degrees less, but the mesh in this section needed to be pulled more, and in this